Let's talk about calculating your index of hydrogen deficiency or your degree of unsaturation for molecules containing atoms from group number 5. So nitrogen, phosphorus, etc. Right? So to calculate your index of hydrogen deficiency, remember it's equal to the number of hydrogens in your reference. Remember your reference comes from the alkane with the same number of carbons as is in your unknown, right? So it's number of hydrogens in your reference minus number of hydrogens in your unknown. Let's look at an example. So let's say you're given the molecular formula C7H10 and 2. And you're asked to calculate your index of hydrogen deficiency. So you need to figure out how much ring or double bond or triple bond or a combination is in C7H10 and 2, right? So for anything in group 5, right? For your unknown, you're going to have to subtract based on the number of atoms that is present for your group 5 element. So for example, here my unknown has 2 nitrogens. So it means to get the number of hydrogens in my unknown, it's 2. You're going to do 10 minus 2, right? You have to subtract the 2 from the 10. So if it was just 1, then I would only do 10 minus 1, but it's 2. So for each element of group 5 that you have in the unknown, you subtract that amount from the number of hydrogens that is in the unknown. Okay, so let's do our reference first and then we'll do our unknown number of hydrogens in the unknown. So you're given this. Okay, so let's calculate the number of hydrogens in my reference. So remember, for your reference, it's the alkane with the same number of carbons as is in the unknown. My unknown has 7 carbons, so I need the corresponding alkane that has 7 carbons. So an alkane that has 7 carbons has 16 hydrogen. That's that CnH2n plus 2 molecular formula. 7 times 2 is 14 plus 2 is 16. So the number of hydrogen in my reference is 16. Okay, let's look at the number of hydrogens in my unknown. Right, my unknown has 2 nitrogens and 10 hydrogens. So we're gonna do 10 minus 2 because of the hydrogen. So it's 8. I have 10 hydrogens, so you please do not make this mistake. You take the 2 from the number of hydrogens in the unknown, not the reference. The reference sits by itself, right? What you're messing with is the unknown, okay? So this is going to be 8. So this is 8 divided by 2. We don't do much math in organic. You can divide by 2, add 2, you're good to go. So the reason why we're subtracting, and generally you don't get asked this question, right? But I'm going to tell you, it's because whenever you introduce a nitrogen into a hydrocarbon, it brings an extra hydrogen with it. So you have to account for it by subtracting. Okay, if you don't remember that, that's fine, but remember, for nitrogen you must subtract. Let's look at one last example on this. What if you're given C5H9N? This is a 5. Okay, and you're asked calculate the index of hydrogen deficiency or the degrees of unsaturation. So you need to know how many double bonds, triple ring, or combination. Okay, by the way, the value you got here, 4, means that the number of degrees of unsaturation is 4. So for C7H10N2, however that combination is, and you can go look up a structure on Google, you will see that the number of degrees of unsaturation needs to be 4. So whether it's one ring with 3 double bonds, one ring, 2 double bond, one double bond, and a triple bond, right? Always remember your triple bond, by the way, is 2 degrees of on saturation. All right, so let's look at C5H9N. So remember, You write your little formula. You must remember the formula, by the way. It's generally not given. It's something you have to memorize. So the number of hydrogen in your reference minus the number of hydrogens in the unknown divided by 2. So the number of hydrogens in my reference, find the unknown, it has 5 carbons. So you need the alkane that has 5 carbons. You need to ask yourself how many hydrogens does it have? 5 times 2 is 10 plus 2, 12. All I'm using is the molecular formula for an alkane, CnH2n plus 2. Number of hydrogens in my unknown. So here's the unknown. I have 9 hydrogens, but I have a nitrogen, which means I only have one nitrogen, so it's 9 minus 1, which is 8. So this is 8. This is 12. 12 came from here. This is 4 divided by 2 equal to 2. So C5H9N has 2 degrees of unsaturation. That's how you approach your questions with nitrogen. So remember, if you have a halogen, you add, right? If you have anything from group 6, do absolutely nothing. Group 5, you subtract. Okay? So add, I know for 6 you can remember. The word nothing has an O in there, 6 starts with an oxygen. For the halogens, you're just gonna have to find a way to remember. You could probably use halogen, add, had, and group 5 is the only one that's left. You subtract. Create some genius way to remember.